and we'll go from there. So I'll get back to you, Jeff.
All right, thank you. Do I have to wait for a countdown? Nope, I'm good. All right, hello, good afternoon, everybody. Last session of the day, so got to try to keep you guys awake for a little while. My name is Jeff McLaughlin. I'm a director of technical marketing. I have Imran along with me. He was there, but he will be joining us hopefully in a little bit. Imran is a technical marketing engineer. And just a quick background, I wanted to let you guys know something about the organizational structure of our technical marketing team, because in the great Cisco tradition, we had a reorg. Happens a lot here at Cisco, but it's really a good reorg, and this does affect you all because you work with TMEs a lot. You know a lot of the TMEs on my team. And it used to be that we had TMEs scattered throughout our enterprise organization. Now we have all those TMEs reporting to a single vice president, Carl Solder, who's in the back of the room. So that's good, right? Because we've taken the TMEs who work on platforms like routing and switching and wireless, TMEs who work on DNA Center, TMEs who work on ICE, software-defined access, and we're all working under the same organization now, right? Which is good because you know that's going to be reflected as we go forward in the products. That's a complaint you hear a lot, that our products sometimes look like we're not talking to each other. Well, we're all on one team now. On my team personally, I have TMEs who are working on SD access, which I've had for a couple of years now. I have TMEs who are working on ICE, okay? So we're connecting the SD access TMEs with the ICE TMEs because those are integral, right? Those are very closely related. I have TMEs working on APIs for our controllers. So northbound from DNAC, from Viptela, from ICE. So again, you know, those products, it could be hard to consume the APIs, but we have TMEs who are working across those products now on my team. So I'd love to talk to partners about that because I think APIs and programmability are a great area for partners to provide services to customers, because a lot of times customers don't want to learn that. So we've had this org change. It's been great. I think you're going to see a lot of benefits from that. You can still reach out to the same TMEs who you know and have been working with, but the chances are they're going to be cross-pollinating and connecting in ways they weren't before. So I want to let you know that, first of all, before I actually get started. So I'm here to talk to you today about the software-defined campus. This is the last section in our Campus of the Future day-long session today. And I wanted to start out with a bit of a story, okay? I was talking to a partner, SE, not very long ago. It was just a couple of weeks ago. And we had done an update for this SE because we had not explained to them the changes to software-defined access since the 1.1 timeframe. So there have been a lot of changes. You all probably know about them. This particular SE hadn't had an update in a long time. One of those features was Layer 2 flooding. You all probably know that we now support Layer 2 flooding and software-defined access. And so this SE came to me after the presentation. He said, I want to talk to you about Layer 2 flooding. I said, great, isn't that exciting? We have Layer 2 flooding and software-defined access. And he said, Jeff, I've had Layer 2 flooding since like the 90s when I first bought a hub and plugged 2 devices in, right? Why do I need VXLAN and Lisp and DNAC? Why do I need all this stuff to get Layer 2 flooding? It seems like it's more complicated than it needs to be. And I think that for him, we had to take a step back because I think he was missing the point a bit. And I think we're to blame for some of that, right? Because you've probably seen this slide. The way we often explain software-defined access is in terms of, you know, Lisp and VXLAN and you know, group tags and all of that, right? And we're kind of down in the weeds, and we're not actually explaining the value of it. So what I really liked about the way we structured the VT this time with the Campus of the Future segment is we're actually explaining the foundations of why we need this in the first place, right? Because if you look at how networking used to be, anybody work with this box? Cat 5K, a few of you? All right, awesome. Sean Vargo's in the back, like I know you did. You don't have to raise your hand. If you look at how networks were built back in this day, this is the first Catalyst switch that I worked with, and I built a network on this thing. There were 0 wireless clients, right? There was no wireless on that network. Obviously, the world is different. As they pointed out earlier in the Campus of the Future session, people are carrying, you guys know, 2, 3 wireless devices in their pockets at any time. We have issues around guest access and BYOD, right? So the era of the Cat 9K, even though the box may look very similar to the 5K, right? Under the hood, it's very different, and the challenges that we're trying to solve are very different. And so for us, SD access isn't just about, any particular solution. It's not about VXLAN, it's not about Lisp. It's really about how do we solve the problems of the campus of the future. This is not just any architecture. We see this as the architecture going forward. Now, there are a number of changes that are going to be coming out over the course of this next few months related to software-defined access that I'll be talking about in this presentation, as well as Imran, that will help us move towards the campus of the future. One of the things that I did is a little bit of an exercise before I did this presentation. I actually pulled our system requirements document for software-defined access. The original document, it was actually called user-centric infrastructure, so a totally different name. This is from a couple of years back. And I looked at the first few pages of it where we have our preamble and our introduction as to why we built this in the first place. This is before any of you even knew what software-defined access was. What was interesting about it was, again, it wasn't talking about VXLAN and Lisp and protocols. It was talking about the transformational changes that the network is undergoing. BYOD, Internet of Everything, which is, I guess, what they were calling Internet of Things back then. All of those challenges we were aware of and we anticipated. So we built this not to just have some kind of a project in our garage to throw together a few protocols. We built it as the solution and the architecture going forward. In terms of the deployments of software-defined access, we've had a lot of success, and I want to thank the people in this room because a lot of you have participated in this and helped us to drive this success. We have 370 plus production deployments, and that's nothing to sneeze at. That's a very fast ramping product for us. Just like Cat 9K is a very fast ramping product, this is very fast ramping. I mean, 370 plus is nothing to sneeze at, but we want to go beyond that, and we want to use your help to get to 1,000 and beyond 1,000. And the deployments, I sometimes joke when I was a customer and they'd put up a slide like this, and I'd be like, yeah, whatever. They probably just grabbed those logos off the internet and slapped them on a slide. But I can guarantee you these are real deployments. As many of you in this room know, maybe you've been involved with one of these or more. I remember Amore Pacific, the SE for that particular account, was calling me on weekends. They deployed in the 1.0 timeframe. I mean, they deployed a huge, thousands of users, production network on SD Access 1.0. And I don't care how much confidence you may have in your product, 1.0 is always a little bit risky, right? But they went ahead and did it, and they're still on it. They haven't taken it out of their network. It's been very successful. AstraZeneca is another great example, a healthcare company. They've been on SDA since the 1.0 timeframe, and they're very happy with it. I'll highlight just a couple of key customers just so you have an idea, and then we'll get into the features and the technology. Piedmont Healthcare in Alabama. This is a very successful deployment of thousands of endpoints, and this is a healthcare network. You think about a healthcare network, they have all kinds of challenges that a lot of other networks don't have. For example, they have a lot of medical devices, and obviously uptime is critical for those, right? They can't fail because lives are at stake. But beyond that, they have other challenges like those medical devices will be running Windows 98 because they certified on that years ago, and they can't actually update it because they'll have to go through their certification process again, right? But they deployed Cat 9K here, 3,800 APs, and they've successfully been running software-defined access. Another example that I like, a University of Northampton. What's great about this customer, I mean, it's a university, so they have their own challenges, right? We all know universities. I like how this slide says, I think it says somewhere there, yeah, provide network services with agility to the millennials, because we all know the millennials need their Wi-Fi, right? And you have challenges of separating student and faculty traffic and all this BYOD stuff. But what's interesting about this deployment is we have 1,400 APs, so this is our largest SD Access fabric-enabled deployment. I'll talk a bit more about the wireless in a bit, but you guys probably know that there's fabric-enabled wireless and over-the-top wireless. OTT basically is, we build a wired SD Access fabric, and then we just run the wireless non-fabric. Okay, this is a great example for anyone who has questions about whether they should do fabric-enabled. This is a very successful deployment doing SDA fabric-enabled wireless. All right, so where are we going with SD Access today? Well, to know where we're going, we've got to kind of take a step back and look at where we've started, right? And it started with one fabric. That's what we could do in the original 1.0 timeframe: border, control plane, edge nodes, a couple of VNs. Okay, that was the 1.0 timeframe. Then we added more than one fabric, right? This is the ability to do multi-site or distributed campus. When we originally released distributed campus, we could not do an SD access transit. So that means you had an IP non-fabric transit right between those different sites. Then we released the SD access transit. So that enabled you to do full software-defined access policy and segmentation end-to-end across your sites. Okay, that's already released. You've had updates in that before if you've been to the VT. Where we're going next is multi-domain. You'll hear about that. I'm not sure what day they're doing it for you, but there'll be a multi-domain session. So you'll be hearing about that. We're working on connecting end-to-end software-defined access data center fabrics and doing that over SD-WAN end-to-end. Okay. Scale. I know Bipin talked about this in the earlier session. We supported 25,000 endpoints in the original version of software-defined access, which is great. That's a very significant size network. Both the new 112-core DNAC appliance, we're moving towards 100K endpoints, okay? So we're able to deliver large scale with DNAC and software-defined access fabrics. I think Bipin also mentioned this, so I won't belabor it, but he probably talked to you about the 3-node HA cluster that we can do for DNAC. That does apply to software-defined access as well, starting in 128. So SDA fabrics will actually, of course, continue running if DNAC goes down. It's not a part of the forwarding path for DNA. It's not even a part of the control plane technically. But customers still want resiliency and redundancy for every part of the system, right? So now we have 3-node HA. Another important development, single DNAC to ISO. Sorry, that's not the development. Again, we're starting at the beginning here. So single DNAC to ICE is where we started, right? We could integrate one DNAC to an ICE. Now I'm talking about the PAN node, right? You could have multiple PSNs, but we couldn't go to more than one ICE, okay? So we now have a capability, which will be coming to do DNAC to multi-ICE for guests. So what does this mean? Well, we have a number of customers that want to have a different ICE administer a different ICE for their, say, their corporate users versus their guest users, right? They don't want them on the same ICE. So we have the ability to split that now and go from one DNAC to multiple ICEs. In addition, I don't have it depicted on the slide. We're going to be able to go multi-DNAC to ICE. Okay, so right now we have that one-to-one relationship. We're going to be able to go multiple in both directions. In addition, we're increasing the deployment flexibility of software-defined access quite a bit. So the way I'm going to do this is I'll show you a picture of a fabric, and we'll start, I believe, at the 1 o'clock position and go clockwise. I have to always think about that a little bit. So we'll start with wireless experience. We're going to look at the different ways we're improving all these different components of our access fabric. Okay, so wireless experience. I mentioned the University of Northampton before. So we've had a lot of customers and our own SEs, partners, going OTT with wireless. In other words, they don't want to deploy the fabric-enabled wireless. Well, why would this be? There are a couple of reasons. I think probably a lot of you know them. One, it could be that they don't have Cisco APs and they're not willing to replace them. That could be one. Another reason would be they have Cisco APs, but they're Wave 1 APs, so they're not supported in the fabric and they don't want to replace them. But the question that you have to ask your customers when you're positioning software-defined access is, do you want wireless to be a second-class citizen? If you think about it, you deploy this fabric and you have all the benefits of segmentation, and yet you deploy your wireless over the top. You're not getting any of those benefits. And with the exception of a very few customers, who I've seen like military customers, almost everybody needs wireless, and the vast majority of our clients are wireless. So the good news is, we have great new APs. I think you've heard about those today, the 9100 series access point. Why would you buy one of these and not give it full access to the advantages of software-defined access, right? Why would you? I mean, if you're putting in a nice new AP like this, you want full fabric end-to-end. So this actually, the new things that are coming out actually give us an advantage in positioning wireless for software-defined access. Like if customers didn't have a motivation to upgrade their APs before, with all the new stuff that's coming out on the wireless front, they should be motivated to do so. Right? In addition, With the Cat 9800, we have several wireless deployment options that we didn't have before. Now, the 9800, I'm sure you're all familiar with it. It runs iOS XE, which is great. I mean, this is again, getting to that end-to-end story. We had AirOS before, which was fine. There are a lot of networks built with AirOS. We still support it. But this gives us consistency end-to-end with our wired platforms. Another great thing that I always like to talk about, I used to do programmability a lot. I still do a bit. Because we have iOS XE here, we have full netconf yang support. When 9800s are deployed in a fabric, we're doing netconf yang day one from DNAC. So it's just a great platform. But it gives us options that we didn't have before with AirOS. So for a good-sized campus, like medium to large, you can deploy a physical Cat 9800 just like you would a WLC from AirOS. We can also run it virtually. It doesn't have to run on a physical appliance. We can run it on a KVM or ESXi cluster. But my favorite option is the embedded option. We can actually run a wireless LAN controller embedded on a Cat 9K switch. It does have to be a 9300. And what's great about this, you know, if you think about it, I mentioned before that the Cat 5K and 9K, I mean, they look kind of similar when you just look at the box. But this would not have been possible without the developments at the hardware level for Cat 9K. As you know, the Cat 9K has the ability now to do application hosting. Thus, we can host things like the WLC on the box itself. So this gives us a couple of other options that I'm going to talk about in a little while when I talk about branches. So there are a lot of new options for deploying wireless for software-defined access, which hopefully will help you to move customers away from over-the-top and towards fabric-enabled. How do we connect branches? Well, you probably know about Fabric in a Box. The question is, we have a headquarters, we have control plane, border, edge nodes, we have that fabric set up there, but we don't want to put all those devices in a branch. Branch is small, obviously. So Fabric in a Box has been out for a while, where we take the control plane, we take the border and the edge node and put them in a single switch or stack of switches. Again, this is a 9300 only, Catalyst 9300. So this is great. There's something missing. Do you notice something missing from the Fabric in a Box picture here? We noticed extensive surveys of our customers and focus groups that some of our customers like wireless, you know, in their branch. A few of them do. They actually use wireless. There's no wireless in the original version of this. So the good news is, starting in 1.2.10, we now have Fabric in a Box with embedded wireless. 1.2.10 is shipping now. So we've taken that wireless LAN controller, the Cat 9800 iOS XE-based controller, and we're running it on that Fabric in a Box 9300 or 9300 stack. Okay. So we solved that wireless problem. In the first version, obviously, it worked, but the wireless is an important component of Fabric in a Box. It's there now. IoT devices. So this is a feature that we've talked about a bit. It's been in beta for a while. It's going GA in 1.3. 1.3 is right now targeted for next month, I think. Software-defined access extension. So just to go back and reiterate what the problem was before, you know, if you think about it, you build your software-defined access fabric. It's great. You have these fabric edge nodes. The only problem is you have IoT devices or maybe devices on your factory floor that aren't connecting to hardware, which is supported by software-defined access. So you have your main core SDA fabric, but how do I get my, you know, IoT devices like my IP cameras connected to the fabric? Well, it works great if you have 9300s all over the place, but what if they're connected to a Catalyst digital building switch, a Catalyst 3560CX, or an industrial Ethernet series switch? Those cannot be fabric nodes at this point. So with extended node or SD access extension, we have the ability now to take an IE switch or a Catalyst digital building switch and plug that into a fabric edge node and have it at least participate in the fabric to a certain extent. Now, it can't do dynamic host onboarding the way a fabric edge node can. But what you do is when you onboard this extension node, you assign it an IP pool, and at least when those frames from your IoT devices or your factory floor come in They'll pass through your extension switch, hit the fabric edge, and then they'll be a part of the fabric. They'll be getting SGTs and all of that. So it doesn't give you quite the flexibility of a full-blown fabric edge node, but you may put all of your IoT devices in a single IoT VN or SGT, and now they can participate in the network. So this, again, you may have seen it if you've been working with SDA recently. It's there in beta, but the good news is 1.3, it's general availability, so you can start deploying that to your customers with confidence. There will also be port channeling available for this as well. That was a request. It's not in the beta version, so we will have port channeling between the fabric edge and the extension node. Moving on, how do we handle the explosion of IP devices? I think we all know the answer to this question. I took a class back in like the 1990s, I think it was, on the basics of TCP/IP, and they said, we're going to run out of IPv4 addresses in the next 2 years. And I'm thinking, yeah, it was like 98, I think it was. And we didn't do it, but we have a lot of customers now that are looking for IPv6. So this is very simple. Software-defined access did not, before 1.3, support IPv6. We have a lot of customers that are mandating IPv6 now. They will not deploy without it. So like I said, very simple. The good news is we now support IPv6 starting in 1.3. The way it works, it's very simple. These are first of all, IPv6 clients, okay, so IPv6 hosts. The underlay, the overlay host, in other words, the hosts who are in the overlay, the underlay is still IPv4. Okay, so we don't have v6 in the underlay at this point. However, for most of our customers, that is adequate, right? They just want their laptops to run IPv6. That's what they want, or maybe dual stack. Okay, so this will support it now. You can plug it in the fabric. You can do all of those things that you would do with IPv6 in a normal IPv6 network, like network discovery and link local addressing, et cetera. If you have a customer that wants end-to-end and they really need the underlay in v6, we'll get there. We're just not there yet. How does this work? I know I mentioned I shouldn't talk about protocols too much, but I'll give you a little bit of a technical explanation of how it works, because it's actually very simple. If you know how Lisp works, if you know how it works for v4, we do a lookup on a v4 address, which is the address of, say, a host like a laptop or whatever that's on the SD access fabric. The Lisp control plane, which is a Lisp map server, right, gives us the RLOC address, which is basically the loopback address of the switch that host is behind. IPv6 works exactly the same way. We're just looking up a v6 address and getting a v4 RLOC back. Basically the same thing, just supporting v6 now. You can define v6 pools, you can import them from your IPAM, et cetera. So when I did this presentation for our SEs, we had one person who was sitting right there in that empty chair who was like the biggest v6 advocate in Cisco, and she sent up a little cheer. So this should be good news, though, because we have a lot of customers who really do demand this, and they won't deploy without it. How can we make guest access more secure? This is coming up later. It's not in the next release, but it's coming up soon. So if you think about it, the way SD access works now for guest is, well, there are a couple of things. First of all, we can, with the advent of multi-site, we can stretch a VN across multiple sites. We can do that. That's great. So we have our guest VN, and it's across multiple sites. There are a couple of problems. Number one, we have to have a different IP pool at each of those sites, right? We can't have the same one across. And let's say we have our guest VN, we have to use a local border at that site to get out of the fabric. So what that means is you either have to use your enterprise border or set up a special guest border, but it has to be at that site. So we're going to be introducing a couple of new things to help make the guest process easier. First of all, you'll have the ability to use the same IP pool across sites for a VN, okay, for guest. That's the first thing. Second of all, you'll be able to use a common border across all of those sites for your guest traffic. This is a very common deployment scenario. We get this request a lot from customers. Typically, they want to locate a border somewhere in their DMZ, and send all that traffic out the DMZ and not have to use the local site border for SDA. So this is really an improvement over how we're doing guests now. You get the same common pool across all sites, and then you can go out a DMZ border. Very quiet here today. Well, we'll have Q&A in a little bit, so hopefully you'll all, I know the last session of the day is tough. So, all right, border config. How can we make this easier? You all know about the Fusion router? All right. If you're not familiar with it, here's how it worked in SD Access. So we have the border, which gets us in and out of an SD Access fabric, and we have our virtual networks, right, inside the SD Access fabric, like our employee, contractor, IoT, whatever they might be. And then typically we have some shared services that are sitting in a data center somewhere, and that's your DHCP, your DNS, your Active Directory, ICE, whatever it may be. And those shared services from an SDA perspective are in the global routing table. And these virtual networks are implemented with VRFs under the hood. And so we have this problem of how do we get the routes for those shared services into the virtual networks. And the way we've done this in the past is with a Fusion router, which some people refer to as the Confusion router. If you haven't set one up, if you have, you'll know why. And the way this works is like this. We have our global routing table connected to that Fusion router, and we have our VNs connected to it, so we actually have to configure the VNs manually on it, and then we do route leaking between them. So we leak the routes from the global routing table into each VRF, and we leak the routes from the VRF out to the global routing table so the shared services knows how to reach those VNs. Now, there's a lot of interesting magic to making this happen. How do we configure it? Just a little refresher. Well, first of all, on the Fusion device, you have to set up the address families. You have to set up your virtual networks, actually, configure your VRFs with the appropriate address families under it. And then you have to set up, of course, an interface and make sure you do VRF forwarding on the sub-interfaces, because you actually have to do sub-interfaces. That's between your border and your Fusion. And then, of course, you have to ping, make sure that works, because if it doesn't work, you shouldn't go any further. Then, of course, you just have to do BGP, set up a few address families in BGP to activate those VRFs. And then you just have to set up a prefix list, tie it to a route map, and tie that to your VRF definition, and you're done. This is a very popular feature with people studying for their CCIE service provider. So obviously, this is a little bit complicated, right? And this is how we had to do it to connect our shared services in. It was not easy. It was not a very popular feature. Oh, I forgot a step. Imagine that. Even I did. If you have two Fusion routers, you have to do IBGP between them. So, you know, all right, you get the point. So the good news is this will, this new feature, extranet, will allow us to remove the Fusion router in certain circumstances. Won't get rid of the Fusion router in every circumstance. If you want to go from VN to VN inside the fabric, you'll still need a Fusion router or probably a firewall. But for getting the shared services and to the internet, you will still, you will be able to eliminate the Fusion router. How does this work? It's actually very simple. Right? You'll connect your global routing table and your VNs into the border, so there's no external device. And you'll define a virtual network as the provider. That's on the right side of this slide. So here we're defining our, actually you could define either a virtual network or the global routing table, by the way. So in this case, we're defining our shared services and our global routing table as a provider. And that's where your DHCP and DNS and all those things live. And then we can define certain VNs as subscribers. So the subscribers, or consumers, excuse me, we changed the terminology on it. So those consumers will consume the services of the provider. And this is done with a GUI workflow. There's no CLI. It's just done very simply. One of the things that I think is important, we often throw around terminology like business intent. You'll hear us say that a lot, right? Business intent and intent-based networking. We lose sight of what that means. And an example I like to use, I just bought a house, and I've lived in an apartment my whole life, and buying a house in California means I'll be living on bread and water for the next 25 years. But one of the things, I get the house, and I have a garden now, and I've never had to deal with a garden before. and I have to figure out how to water the garden. And the house came with a system, and you have to go zone by zone and configure how many minutes each zone gets. And if it rains, you have to figure out, should I run it? Should I stop it? How long should I stop it? If it gets hot out, I have to figure out, how much more should I be running it? The idea of intent is that I just want my sprinklers to work. I want a system that figures out for me when to water those different zones based on the weather and what types of plants are there. And that's what I put in, right? I put in an IoT type of system, a automated system to do that. Now, I don't have to think about it. So with the Fusion, it's exactly the same thing. I remember the day when being able to do that kind of configuration, like I was just showing you, kind of made you a really great network engineer. Like, yeah, I can do that. I can do VRFs and all this complex BGP. But now what we're finding is most people just don't want to deal with that. Like, they don't want to sit there and have to configure that and troubleshoot that and make it work. It doesn't make you cool anymore to be able to do that. People just want to click the button that this is where my DHCP is. These are my consumer VNs, and it just works. Right? And so that's what we're moving towards now. And you'll see as we bring in extranet, that's what it'll be all about. Just picking consumers, picking the provider, and it'll just work. All right, so those are some highlights of the developments with software-defined access around scale, where we've been, and some of the new features that are coming. So now I'm going to bring up Imran. Imran's going to talk to you about the new developments in segmentation and policy. So Imran.
All right, thank you, Jeff. All right, this is working. Okay. Good evening, everyone. My name is Imran Bashir. I'm a technical marketing engineer in the same business unit as Jeff. But more importantly, I'm standing between you and the beers. I'm the last guy out here, right? But we'll try to get back Jeff in so he can do some closing as we go through. So I'll be covering a few things today. We'll go over segmentation fundamentals, and promise I'm not going to teach you segmentation, but we'll look at what is segmentation today, what are the pain points that you're dealing with segmentation today, and how can we address them. Next, we'll go over ACA. If you haven't heard about it, it's called Access Control Application, and we'll talk about more details about what that application is. But it's a tool that can simplify rollout of segmentation in your network. Then we'll cover policy analytics. That is the last section in terms of what we can see in terms of policy analytics and how can we help you to automate that application of policy on the network. So all of this is tied to segmentation, and that's why the policy workflow comes in. And before we go further, everything that I'm talking about today will be run through the DNA Center. So we're not showing you 3 different products. It's one single product, DNA Center, and it has all these applications that's implementing the segmentation for you. Now, if the stars align, I will be able to do a live demo. But if they don't, I do have a recorded demo. So we'll be okay. So before we get into segmentation, one thing that I typically like to talk about is let's understand the need of segmentation. And we'll go over some traffic flows, east, west, north, south, just to understand what it means. So I'm showing an example of an attacker. And what the attacker did is that simply went to social media and got your credentials. Based on that, I'm able to formulate alleged emails that looks like it came in from LinkedIn. And I'm just picking LinkedIn as an example. Nothing bad for LinkedIn. But once I get an email, what I'll do, I'll definitely click on yes, accept the invite. And then that is where it's an opportunity for a backdoor malware that could be dropped in your machine, right? Once that happens, the malware is in your enterprise. It's in one of your computer. If it's programmed right, it's going to go try to find more machines and try to move laterally. And then once it becomes the admin, it can actually attack your crown jewels and just start exfiltrating the data, right? As simple as that. So there you go. Data comes in, and I've hit go. That's when you start getting those emails. How much would you pay me to give it back to you? Right? So what did we learn here today? We looked at a couple of things. There was a north-south traffic flow, which means the user can go out into your data center applications, and vice versa. There could be a flow from your application that is coming back to the user. And yes, we have many tools today for this one. You can use firewalls. You can use a number of tools to detect and stop that. What's more important is the east-west flow. So the moment that malware came in to your network, if you were able to stop that east-west traffic flow, you could have just killed the propagation of malware right there, right? So it's very important to understand that need of segmentation on an east-west flow. Another thing would be that if I look at segmentation today, Yes, you can deploy multiple VLANs and you can start putting segments into VLAN, but it does come with a cost. There's more configuration, there's more complexity, and if you look at these firewall rules on the top towards your left, how many of you actually take a firewall rule out of your firewall, production firewall? Nobody. Exactly. I wouldn't touch it, right? Because my batch wouldn't work next day. Anyway, so with that said, there is complexity, right? Now with DNS Center and the whole SD architecture, we have simplified a lot of things. I can enable macro segmentation by automating a lot of processes, and we'll go over there. But even within a VN, we'll talk about how can we segment and implement segmentation that makes more sense. All right, so now that we understand anatomy of an attack and we understand what needs to be done, these are the high-level things. So basically, we need something that sets up segmentation end-to-end. Just like Jeff said, what is my intent? My intent is to block a malware. My intent is not to create a bunch of configuration that just gets me there, right? Secondly, mobility. When these endpoints are moving from one network to the other network, our new architectures have enabled that mobility to be so easy. You can now move these endpoints within a fabric or outside of the fabric without impacting any of the network access issues. For example, in a hospital environment, you go and they test your blood pressure and all these things. Those things are on wheels now. So they're basically mobility on a wireless network going from one room to the other room. Now, can you afford changing IP address on those machines? Probably not, right? But those machines are moving across the network. So with that said, we need a more effective technique in terms of still implementing segmentation when these endpoints are on mobility. Next thing would be IoT, and Jeff touched about that. We'll expand to that more. And the last thing would be all this segmentation. We have products that works in data center. We have products that works in multiple areas. So just to throw some name now, ACI. ACI has a segmentation story that works within the data center, all the EPG stuff. So if you have your segmentation on the campus, how do you actually take it to the data center and have an effective end-to-end segmentation policy? So whatever we're designing here, we're actually looking at the entire architecture, and we're enabling that segmentation from all the way from the user to the device to the IoT device up into the stack to the application where the destination lives. All right? So with that said, SD access certainly enables all this segmentation. We give you multiple levels of segmentation. We can give you macro segmentation and micro segmentation, depending what you need today. And then it just takes that limitation of VLAN or subnet segmentation out of the picture. So you can effectively segment all these points, all these users and devices by using something called SGTs or even macro segmentation on a VN level. And the biggest thing I like is that you're defining one consistent policy. If I log into my DNS center and I'm writing an intent-based policy, that is pushed across my fabric. So whether it's wired, wireless, or VPN, I'm getting the same level of access and the same policy, okay? And the last thing is that a policy follows identity. So any policy that you write today is now based on an identity. It's not based on an IP address or a static MAC address. And that identity could be multiple things. It could be a user in Active Directory. It could be a device in LDAP. It could be an attribute coming from your MDM server, right? So you can club in all those identity and still formulate the policy that you intend. Okay, so I've been talking about SDA and some TrustX stuff. Let's see how these work together. If I look at a fabric, I do have users and devices in the fabric, right? And absolutely, you can start segmenting on a macro level by using VNs. So the first recommendation would be if you have IoT devices, which are not talking to your user devices, and a classic example that we get is that you have an HVAC machine vector and you have users and employees. I don't see a reason for HVAC machines to talk to the user unless they want to change temperature all day, right? So that's where you can start putting them into different VNs. Now, we do understand that there could be multiple types of devices and multiple types of user. So in that case, now you can start doing micro-segmentation. That is where the SGT or scalable groups comes in, and within the same user VN, I can start controlling my employees can talk to contractors, and if they can, what is the policy, right? So think about that. Slide 1 talked about the east-west malware propagation. If you have a technology like that, you can instantly block that malware from spreading east to west, right? I can even write a policy that if the two users have the same SGT, let's say employees talking to employee, yes, they can communicate, they can exchange files, but they cannot exchange malware. So you can go to that granular level of policy. And obviously, the magic comes in the ACLs. So between the group, it's controlled by SG ACLs as we speak. OK, so that was it about a policy intent. Now let's go over how this is done. So what you see towards the right is a screenshot from our access control application. And we'll go into more deep dive. We'll look at a demo as well. But it's so easy to apply policy. I can simply say that when my employees, this is right here, are talking to employees, I don't want them to exchange any malware. So in this case, even the east-west traffic, these are two users sitting on the same switch. And yes, we are saying the same layer 2 network. But the moment traffic goes across the port, I can look at the SGTs. I can start applying the changes, or I can start applying the policy. Even more so, let's say that this employee becomes infected. So if you have multiple systems to detect that change, for example, you're running StealthWatch, and StealthWatch says, hey, this endpoint looks malicious. It used to be an employee, but now it looks like it's sending all this data to this unknown destination or some bad destination. So what we can do is that based on that traffic flow, we can instantly change the SGT value of that user. So I'm still an employee. I'm still in the same port, but my policy has changed. And now with this policy, the moment I'm marked as infected or suspicious, I cannot go and talk to other employees. I'm basically quarantined into one corner, right? And there are ways you can make it automatic, you can make it manual, but typically the use case is that, yes, in most cases, people would like to block the user, depending on the type of the user. And then to put them back on the network, we do give you tools to automatically put them back if they're back clean. But typically, I've never seen any IT admin putting the users back in without further analysis. Okay. All right, let's talk about one more thing. So just to expand on the use case, this is an employee. Traffic comes in, and I'm accessing all my SIM servers. But my traffic is detected by my next-gen IDS or my SIM. And through that, that tool is now telling me, hey, this user is infected, right? Now, two things to note on this slide. First thing is that if you look at the tools today that are detecting the malware, for example, StealthWatch or Firepower, do they have any user identity? They don't. They all work based on an IP address, right? An attacker can flip on or change IP address all day and come right back to you. That's why when these tools integrate with our DNA architecture and ICE and all that stuff, we can start giving them the user identity. That's why I said that when you apply these policies are based on identity. Now the StealthWatch would exactly know that this is an employee, right? And the moment it's marked as infected, these tools can just push or tell ICE to go and change the network policy by using pxGrid, right? And we get all these questions that, what are these APIs? What is pxGrid? Well, that could be a different lecture, but what we're trying to say is that it's designed for a very, very high-scale network, because we understand that under an attack, there could be multiple changes for user and endpoints. So in that case, if you're doing an API would do maybe 8 a second or 10 a second, and that's it. But this can really absorb high bandwidth and start changing these users' access as we go through the network. All right? It's very simple. The moment notification comes in, ICE can take an action and inform the network to change the policy. Eventually, ICE will work with the network to apply the new policy on these users and devices. All right. So this is another screenshot of policy, and you can simply see that I can start writing my policies into access control application. For example, this says contractor to developer or media to something. And these policies are just defining sources and destination and what happens between those sources and destination, right? So the simplest way to look at SGT or the whole policy metrics or microsegmentation is that there are three main elements. There is the source tag, which you give it to the user, but tag by itself is nothing. But all the magic comes in these policies, that when these tags exchange traffic between them, these are the policies that would allow or deny them based on what you have configured, okay? And the third one is matrix. So with that said, let's step into access control application. So first of all, what does this offer? It's giving you a new user experience, which means that when you're writing these policies, they're very easy to write. And we'll go through a detailed demo that shows the value of writing these policies. And then everything that we talk about here is basically enhanced policy definition. So making sure that you can write policies based on sources, you can write policies based on destination, or a combination of those. And it's within a few clicks, the moment you do that, it just gets implemented on the network, right? The next thing will be integration. So this does also provide integration with ICE and DNS Center and all these things. So the entire workflow is very, very simplified. The moment you start using this tool, all the architecture comes in together. And the last important thing would be, yes, you can use third-party AAA servers to authenticate and authorize users and devices on the network with ACA and all these applications. And we'll talk about that as well. By the way, any questions so far? Yes. It's a good way to take a water break.
You mentioned the process of changing the user policy from the ICE or firewall IPS detects the problem, then instructs the ICE to change the policy. We know the policy is one way created from the DNIC to the ICE. Are you saying that manual process to onboard the user again will involve like manual adjustment to the ICE policies after like cleaning the users?
So very good question. I'm just going to repeat it so I understand I get your question right. But what you're asking is that we talked about policies for users, and we talked about when the policy changes, what happens, right? So the way I would architect is that you would have the policy for both the scenarios already baked into ICE. For example, you would have an employee policy, and you would have a quarantine policy, right? So the moment the user is detected that is becoming quarantine, ICE will literally tell the switch to re-authenticate this user. That's it, nothing much, right? The moment user re-authenticates based on the attributes of the user would be given a new tag, quarantine, and you would already have a policy for that tag inside your network. So that's how it works. Correct, exactly, right, good question. Okay, so the key takeaway from this slide is that we're giving you a very easy UI to work with the whole microsegmentation architecture. And secondly, yes, we're enabling you to work with the third-party AAA radius as well as you go through, right? Which means, sorry to break it to you, but ICE is not going away. Which means that even with the new UI and all the goodness that ACA brings in, the underlying control of the architecture is still ICE, right? And I just want to be clear because we do get this question all the time, that let's say if you have a third-party radius server running on the network today, right? Yes, you can still use a third-party server because it's just used for authentication and authorization. But that third-party server does not have the ability to apply SGTs, to apply policies for those SGTs. That's why you need ICE in the network to work with that as well, right? And we can go into details about how these two things work together and how can you apply a third-party server into the mix. I do have slides for that. All right, so just to recap, there are two major functions of ICE. First of all, it's a AAA server towards your left, so it's doing all the authentication and authorization for these users. Very simple, a user comes in, logs in through Active Directory. Even to take a step back, a user comes in and authenticates using .1x. That's your authentication. Then it goes to your groups and other conditions, that's your authorization. And based on that, you are on the network. Right? The second major piece that ICE provides is about groups and policies. So that is where you put in all your SGTs, your SGACLs, and the TrustSec matrix, right? That's what ICE does. Third thing is that as you talk about, ICE does work with the network. So I have a whole bunch of protocols, .1x, MAP, VLAN, and different kind of authentication methods. I have Active Directory, LDAP, and many, many other elements. So ICE can work with all these backend services, and it enables authentication on these network for users and devices, right? So the reason to put this slide out is that there's a clear separation between a AAA services towards your left and the microsegmentation towards your right, which is all the group-based policies. So that is where you should plug in a third-party radius. Yes, all the things on the left, which is authenticating and authorizing a user on the network, could be handled by that third-party radius. So this is where ACA comes in. ACA will simplify the whole group-based policy microsegmentation piece within the architecture and we'll go into more details about how this works. Okay, so 2 screenshots from ACA. Towards your left, you can see a policy view. How many have you seen the ICE trust sec matrix? All right, good. So this is the new tool that will be working with that matrix, and I think the demo will really call out the benefit of using this new tool. It's really, really simple to use it as compared to the ICE trust sec matrix. And towards your right, these are all the policy matrix view. Now, if you're using DNS Center today, 1.2.10, there are a couple of enhancements over here. For example, now you can write policies based on source and destination SGTs by using ACA. So that's coming up. Other enhancement that we did is that by default, there'll be like an ICMP rule. So you don't have to figure out the ports of ICMP and fabricate your policy. You can simply say ICMP deny or allow, and that will do or make the magic. And the last enhancement that ACA brings in is the logging. So right from here, you can start turning on or off your logging for a specific set of these policies, or ACEs, if you want to call it, in terms of ACL language. Okay, integration with ICE. So we talked about that ICE is still in the picture, right? Let's talk about how that works. So towards your left is your DNS Center, and this is just like an ACA logo that you could commit. But what we're doing is that we're creating these SGT, SGACLs, and the policies by using access control application. Just like you do in DNS Center today, but ACA will give you a better UI, right? Once that happens, all these policies will be pushed into ICE. So there's no need to log into ICE and edit any of those policies. That'll be all coming in, right? Other benefit that you'll get with ACA is that if you have an existing ICE and you have some TrustSec policies which are already running in a network, basically brownfield ICE. So the moment you connect this ACA, it will pull all those existing policies into ACA. So you'll have just one brain to work with, not a split brain scenario, and that will just make all these policy configuration easier. Okay? And so that's what happens. The push and pull happens from the ICE and the policy side, and then ICE can obviously work with other elements on the network side, whether your firewall or your stealth watch and all these things. And then eventually ICE will be provisioning all these SGT, SGACLs, and TrustSec policy matrix on the switches. Okay. Let's talk about third party, right? There could be multiple use cases of third party, and the way we've designed is that let's first talk about the Radius use case. So your third-party server is actually a Radius server. It can understand AAA stuff, right? Authentication, authorization, and accounting. But there could be scenarios where third-party is not a AAA server. It's using some other protocol, maybe an SNMP, port bounce, or something like that. So we'll make sure that we've covered both of these scenarios with ACA. Let's talk about the first scenario, AAA. So the way this will work is that you'll go under ACA, you'll configure your policies just like we talked about in the previous slide, and all the policies will be provisioned into the fabric, right? Now, with the help of DNS Center, you will be able to program your switches to talk to the third-party Radius server, basically all the standard AAA server. So you will have a template within DNS Center. You can go and push that template on these switches, so the switches can go talk to third-party server. Now, what will happen is that eventually these users and devices will be authenticating with the third-party server. In return, the third-party server will be sending Radius attributes back to these switches, right? So I'll just go over a small workflow. A user comes in, connects to your white switch, goes through the authentication, and in this case, who is authenticating the user? It's the third-party Radius server, right? Once that happens, the third-party server will come back and apply a policy on your access switch, in this case, the Fabric Edge. Now, one additional thing that this server will do is that it will also push in the SGT on these switches. So it'll actually tell you that, hey, there's an employee authenticated with Active Directory, and based on that, I want this employee to be assigned a tag 10, right? So far, so good? All right. So now this switch has a user with the tag 10, but where is the policy? Because the moment switch gets a tag, it needs to go and find the policy. It needs to get that matrix that, hey, 10 can talk to 20 or 30, and if they're able to talk, what is the policy in between? So that is where the switch will go and reach out to ICE and download these policies, right? So the way we've programmed is that we don't want all the switches to have thousands of policies in every switch. Yes, we can come back and give you more TCAMs all the time, but it has to be more I think, more fruitful. So that's why it will dynamically go and pull these policy that's being used. And if that policy is not used for a certain amount of time, I can't remember the time, but it was like 5 minutes, it does go away as well. So that it does flushes all the policy too. All right, so that's the radius use case. Users comes in, gets authenticated, I get an SGT, that SGT will be pulled by ICE and then applies the policy on the network. Let's talk about the second use case, the SNMP use case, right? So in that case, since there's no radius happening between the third party and the switch, we can't do much. But there will be still radius between the endpoint and the switch. And the reason why? Because we'll still be running MAB, MAG Authentication Bypass Protocol, right? Now, the moment we run MAB, the magic happens in the background, and ICE now has a session ID with that user. So if I dump in 5 different employees on the same switch, ICE will have 5 different session IDs based on MAB, right? So this is very important because ICE will know that what are the users that are attaching on the network, but eventually, once the authentication happens, your third-party radius server will use an API and come back and inform either ACA or ICE. I don't want to finalize that, but that's something being worked on. And based on that, now we can go and change the policy for the network. So it's more like a passive use case. Somebody connects to the network, we can put them to an initial VLAN, an initial policy, or an initial SGT. But after a while, the moment we get this API from the third party back to either ICE or to ACA, then we can go back and change the policy of that user, okay? That's why my preferred method being in security would be radius. That's the right way. You're inline, you're very active, you can change policies. But for some reason, if your server is not radius, then you can always use the new API that we're designing with these third-party servers. Okay. Any questions before we step into a demo? Yes, sir, go ahead.
If you ask one more, we'll just give you a mic, all right? It's a contest.
We'll leave the mic there.
Hey, a lot of people, and I think I asked you this question before, are using ClearPass.
Mm-hmm.
Do they have to have an ICE to run SD access? Yes, or no?
Absolutely.
Because here is you're showing radius, but you still have to have an ICE in order to enforce the policies. So ICE is a must. We cannot replace it with the, although it's a big the integration, APIs, all of that things, but it has to be ICE.
Yeah, you're spot on. Even if you're using ClearPass, ClearPass doesn't have the micro-segmentation technology, right? The entire trust-like matrix and all that stuff. That's why you still need an engine that controls that micro-segmentation, and that's why you need ICE. All right, good question. All right, let's go into a demo.
I have one quick question. When it comes to licensing in a third-party situation, if the endpoints are obviously initially registering through, or not registering, but being captured through radius to the third-party device, is ICE then picking up those endpoints as well, or are they only passing SGTs? Meaning, do we have, what would the endpoint licenses be required for ICE if you're using a third-party identity source?
Yeah, technically, to use TrustSec with ICE, you're consuming a base license. So anytime you have an endpoint on the network, you're consuming a base license. Now, you would also say that, hey, if I need to learn few things by using pxGrid, then I'm using a plus license, right? So if you're not using the standard AAA third-party radius server, using something else, then all the flows would be coming in through pxGrid, right? So these are two technologies that will be used in this scenarios, right? Now, how the licensing works, obviously we have these bundles and so many good license stuff coming on. But absolutely, I won't answer that question, but definitely we can check with PMs for licensing details. Yep, good question. All right. So what you're seeing here is Cisco DNS Center, and this has the access control application. So I'll jump directly into the policy tab, right? Within the policy tab, you can do multiple things. So you can start writing your SGTs, you can start writing your contracts, and you can also write your matrix, right? First thing first, for people who have used the ICE matrix, they really appreciate this matrix. For example, I can clearly see that, hey, when my employees are talking to my development servers, what is the policy? So it pops up right over there. I can see that development servers, employee when talking to development servers, the policy says deny, right? So I don't have to click on a policy, go into further details, and find out what's happening. It's just showing right over there, right? Another cool thing that I like about is that, check this widget out towards your right, right? So in event you have a number of tags, sometimes you lose where you are in the whole matrix, right? So in that case, when I scroll up or down, it actually shows me where I am, right? And if I expand it into a bigger screen, it can be more specific and show me on right corner, left corner, or not, right? Let's go into some filters. So another thing that I like is filters. So over here, I can select a bunch of SGTs. So let's pick up employees, contractors, and maybe development server and apply this filter, right? Now I'm being very, very specific that when my employee talks to employee, what is the policy? Allow DHCP DNS. When my employee talks to development server, what is the policy, right? So within a few clicks, I don't have to go to multiple screens. Right from the dashboard, I can just figure out my end-to-end policy, right? That comes out well. So, and we'll come back to the filter later on after I write a policy, but let's just clear the filter. All right. Next thing up would be scalable groups. So another change you'll see from our previous screen is that, let's take an example of auditors, which is an SGT group. We're showing you the tag value right up front. We're telling you the description. We're actually telling you if this SGT is deployed or not deployed, right? Because traditionally, if you're working with ICE like 1.2, something like that, we can always push a policy to these switches, but it was more like a UDP model. We could never verify the policy. But in this case, we can actually tell you, hey, this SGT is actually being deployed on your network, right? Last thing would be look at the references. So I can clearly see that this auditor is talking to these 22 different destination SGTs, and then what is the contract in these destination SGTs, right? That's also super useful. And in terms of SDA Fabric, I can also tell you that this auditor is now part of the user VM, right? And by the way, yes, we will support these SGTs to be part of multiple VMs or all the VMs. So you'll hear something like VN agnostic SGTs that'll be coming up as well. Okay? So yes, you can always click on a tag and it gives you more information. And you can also find out if this is being propagated to ACI, if you're planning to deploy an end-to-end policy from your fabric to ACI and all the transformations of SGT to EPG and vice versa. All right, that's one thing. The other thing I would like to show you is the access contract, and that is hugely simplified as well. So in this case, if I look at this access contract that says allow DHCP DNS, I can see how many rules this has. So in firewall language, how many ACs it has. So this has like 2 rules. Again, how many policies is it touching? So in this case, your allow DHCP DNS is linked to these 3 different policies as we speak, right? Let's take another example. So in this case, the anti-malware. This has some more AC entries, and the few things that I would highlight is, yes, you can write policies based on source and destination. That is permitted. You can turn off and on logging, and then we give you the ability of ICMP as well by simple click. That would you like to allow, deny SMP, and that's all right here. Okay. Let's go to the policies again, and we'll try to create a policy, right? So very simple. I'm going to start writing a policy, source destination or destination source. Let's pick the first one. It gives you 2 ways of selecting the endpoints. Either you can select by here, or you can go to this view where you can drag and drop these SGTs. So step 1, what is my source? So in this case, I'll just pick up my guest, use it as a source. Step 2, what is my destination? So if my guest is trying to talk to my, let's say, developers, I would like them to not spread any malware. Right here, okay? You do next and save the policy. That's it, policy being deployed. So you're able to create SGT, and you were able to create these policies within a minute. That's the power of this simplified UI that brings into the whole architecture, right? Let's go and verify. So where is my guest user? Right here. When it's trying to talk to my employees, the policy says anti-malware, just like we provisioned it. All right? Okay. So with that said, let's go back to the slide. So what did we learn? We're giving you an improved access control user experience, and we just saw a demo on that. You were able to create this policy within a few minutes. We're also enabling SDA adaptation for third-party radius. So if you have an existing third-party radius, yes, you can work with that radius server with our SDA architecture. And then obviously all this just enables you to sell more, right? And in the end, there's a shorter time to value. So you're basically really seeing the value right up there. Yes, sir.
What happened to bidirectional? It used to have bidirectional. Are they only unidirectional now?
No, they're still bidirectional. So
I just didn't see the option.
Right. So this is again an early product, but you're right. These policies could be bidirectional, or you could define one way and the other way, and that could work as well. Right? Yes.
Side of the room is the VIP this week, and you guys over here are really quiet, so I'm expecting a little bit more noise out of you guys on this side. Go ahead with your question.
How do you integrate this with ACI again? There's just a checkbox, but in reality, how does it integrate with EPG and?
Yeah. So I think this will be discussed during the week as well. But there are two things to think about. When you integrate with ACI, you got to think about the control plane and the data plane. So what do I mean by control plane? So control plane is where the mapping happens. For example, literally you'll say, hey, this is the SGT that's coming in from the campus network, and once it goes to the ACI, somebody has to convert that SGT into an EPG, right? So basically you're mapping SGT to EPGs. That's all the control plane aspects of that, right? And that's all done through the APIs. You go to ICE and you add ACI, and then all the magic happens automatically. So that's all done. Now, once it's done, you need a device that can actually strip out those packets. So take a packet, take the SGT out, and put the EPG in, right? So that's the data plane part of the stuff. To answer your question, to summarize it, yes, you go to ICE, you configure ACI integration, it goes in and configures the control plane, and then you configure a device for the data plane. I think there's a full lecture on that this week, but that'll cover through all the packet walks and details and how that happens. But
we have high level Thursday after lunch. Tuesday, Wednesday, we have 2 hours deep dive. So not the marketing, not the high level stuff. So.
All right. Okay, let's talk about policy analytics. That is another application that's coming on Data Center, right? And I just have one slide on it, but it's fairly quick, and I'll try to see if I can do a demo. So what we saw today is that I can create segmentation elements or elements to enable segmentation, and I was able to create a policy to apply that, right? What this tool offers is a number of things. So first of all, how would you assign that SGT to the endpoint? Visibility. I need a lot more visibility before I can start assigning these SGTs to the users, right? And even when the SGTs are assigned, what are they actually doing on the network? So this gives you a lot more visibility in terms of the traffic flows, in terms of the users and devices, and what these devices are doing on the network, and how are they communicating with each other, right? And you could argue that, yes, StealthWatch does that today, doesn't it? It does. But this tool is working with a lot more elements. For example, if StealthWatch is not there, it can work off some logs and some syslogs and some other tools. So there's a lot more input that is coming into this tool as part of application. And yes, StealthWatch is one of the input as well to this tool, right? Now, once that is done, how about defining these policies for you, right? So maybe I can give you a sample policy that you can use. And in the end, can I see through assurance that what is happening with these users? Are these policies being implemented or not, right? So this is what is coming in first phase, basically the ability to look at the endpoints and observe the behavior in much more better way. And this is what I'm going to talk about, or maybe show you a demo on this one. But absolutely, that's what's coming today, that the ability to look at the endpoints and groups and much more things, right? So on purpose, I didn't want to present more slides, but I do want to show a demo. So this is a video right here. Okay. Again, log into DNA Center and you go to a tab and it shows you the policy analytics tab. So in this case, what you're seeing is that these are all the users and devices. And if you notice, these might look familiar to people who are using ICE today, because these are all the profiling groups that are pulled in from ICE into DNA Center, right? So step one, yes, I can get visibility about the devices and users and the types of devices. But step two is look on the bottom. Now I can start seeing that what are the communication that are happening on the network? How many unique endpoints? How many unknown endpoints? And then how many scalable groups do you have on the network when you're getting all this data across the network, right? So let's do one thing. We're going to go deep dive into one of these Apple devices. And I can see I've got 100 Apple devices and 100 Apple Watches. This is a good ratio. And then if I click on one of these devices, for example, I'm going to click on this Apple device, it now shows me what is this Apple iPad doing on the network, right? Is it talking to more iPads? Is it talking to media server or Cisco IP phone? I don't know why, but it is talking to Cisco IP phone, right? So it actually shows you all these communication. And then if you look at these details, I'm actually showing you the TCP ports, the port numbers, the communication from inbound or outbound, and all those details that are part of this communication. So yes, you can switch and all that. And absolutely, you can switch your view to the scalable group view, and now you can start seeing SGTs as well on the network. And one other thing that I like is that this is a very small number to read, but it's giving you the hit count, that your iPad has tried to talk to these different iPads 47 times, right? All that stuff. Okay, I don't know why I'm moving the screen that much, but I'll just pause it. Okay, any questions so far before I bring back Jeff on the stage? Good? All right, thank you. Hope this was useful.
All right, thanks, Imran. And we'll have time for questions. I just have a couple minutes to wrap up. I did see someone standing at the mic in the back, so feel free to go back there if you do have a question. So we've been through a lot, updates on the SD access side, on the segmentation side. So wrapping up, I want to give you a few resources. First of all, I'm sure you're all big fans of CVDs. So the good news is for CVDs, we're going to be taking an approach. Like I said, with all the TMEs combining, we take a solutions view now. So obviously, CVDs are all about solutions. But we're taking a multi-domain approach with CVDs, and we're going to be releasing some new ones coming up. For this session, the most relevant one is at the top here. So we do have an SD access deployment guide, but it hasn't been updated in a little while. So we have a new one coming out, which will cover 1.2.8 and 1.2.10. So that covers some of the features that we've talked about here today, but not all of them, of course. So do keep an eye out for that. Another thing I want to make you aware of, I think Bipin mentioned this with regard to DNA Center. This is really important. So I think one of the problems that I hear from customers and partners as well is, where do I get information on software-defined access? Like, where's the collateral? A lot of it is here internal at Cisco on sites like dnac.cisco.com, which you can't access without VPN. So one of the things that I'm mandating for my team, I actually asked them to ask themselves a question, which is, whenever they produce an item of collateral, a slide deck or a white paper, why not public? Like, why should this not be public? And if they can't answer that question, they should make it public, because I want all of you to be able to find this information more easily than you can now. I know we haven't done very well on that. So one of the great resources that we have are the Cisco communities. So I've got links up here to the SDA community. These, we have a couple different communities. We have the public community, which anybody can see, and that's where I want the majority of our collateral to go, is to the public community. We also have a partner-specific community. You'll be able to go there for questions that maybe shouldn't be asked on the public side, as well as for collateral that maybe shouldn't be made public. So you'll have a community where you can go for information specific to partners, and to help you sell software-defined access. So we have those two resources. The great thing about the public one is, imagine this, if you want to find the answer to a question, you can just Google it. Hey, I mean, I know that seems like, doesn't seem that revolutionary, but the way we've done collateral in the past, we tend to keep it internal. It doesn't need to be there anymore. So also, we have the collateral, but also keep in mind that the communities are a great forum for asking questions and getting answers to questions. So I've committed my TMEs to be monitoring these communities. So if you have a question, rather than trying to find your favorite TME, you could post it in the community. And I hope you take this mindset as well of why not public, because if you have a question and you post it there and it gets answered, it benefits everybody. Everybody will see the answer, and we'll build sort of a living FAQ based on the questions and answers that are asked there. So please do go to the communities. We built out the SDA resources page already. I have a lot more collateral. I'm meeting with my team the next couple weeks to get figure out what collateral we can put there, and we're going to start moving stuff there and start asking questions. So please go to the communities, and not just for SDA. ICE has already done this. They've been very active if you're familiar with the ICE community, DNAC as well. So finally, just help us to sell SDA. Hopefully, a lot of the changes that we've made will address questions that you may have had for software-defined access, will improve your experience deploying it, will improve your customer experience as well. Take advantage of the CVDs in the communities, talk to your customers about it, and we're here. We do have about 15 minutes or so for questions, or reach out to us directly or in the communities. So thank you again for your time today. Questions? Questions? Everybody wants beer, so they probably want to get out.
Any questions?
We do have a question, so we'll start over here. I think the question's probably for you, Imran, because she was...
I'll come on stage.
Oh, I thought you were asking a question.
Oh, okay.
You're the mic person. All right, you can ask.
Got one here.
Yeah, so for the, are you going to talk more in depth later this week about extranet in 1.3 and how it actually works?
So I believe we cover, so we don't actually have the lab, it does not cover in the labs, but I think we'll cover it more in the deep dive session, I believe.
My basic question is, with 1.3 and extranet, are you automating the config that we would have done prior on the Fusion, or are you using some new methodology?
That's a very good question. So we are not automating the Fusion config with extranet. I actually should have mentioned that. Extranet is a different way of getting the routes from the global routing table shared services into the VNs and vice versa. It uses Lisp. It is a Lisp extranet. So it's not just automating Fusion. So it's a different way of doing it.
Thank you.
Yep. Questions? One over here.
Right behind you.
So just a quick question on the ACA, when the comment was made about, with ACA, working with ICE to be able to work with the third parties for SCTs. But if I'm dealing with, let's say like an assurance, I'm trying to position assurance, customers got some of the third party, would ACA be the right tool to be able to basically gather some of that information to make, assurance more valuable to that customer if that didn't want to deploy ICE? And would ICE have to be in the mix in just the non-SDA deployment?
Yeah, that's a good question. So let's break it down. So first of all, even if today, let's say you're using wireless assurance, right? You do get a lot of data on the users and endpoints. What you're talking about is that ACA gives you the ability to tell you the sources, the destination, the identity of these users and devices, right? So yes, you can pull something off from syslog, but you won't be able to get the actual SGT policies applied to that user and what are they communicating, right? So again, as I said, let's break it down into two more things. ACA is the policy piece, but everything you see will be on policy analytics, right? And that policy analytics can get feed from syslog, from third party, from multiple various vendor. So you pick and choose. If you're not using authentication, you won't just see that data. That make sense? Okay.
Yeah, we've got two things. Tuesday, Wednesday in the afternoon. It's on that, so we can definitely advertise that. Yep. Any other questions? All right, let's give you guys a round of applause.
Thank you.
All right, thank you guys.